Okay, for these problems, we're going to take indefinite integrals, which you may remember be the antiderivative of f of x dx, and that equals another function plus c. Now, for these problems, we're going to be substituting into our answer and finding c and then replacing c in the indefinite integral. So, the problems read like this. If dy dx equals 3x squared, what we're going to do, we need to find y so that y is equal to 3 when, now let's change that. Y is equal to 1 when x is equal to 1. Okay, so the way we would do this is we would start with finding our antiderivative. So the antiderivative of 3x squared is x cubed, and then we have to add c, and then what we're going to do is substitute in the point 1, 1. So 1 is equal to 1 plus c, and then c is equal to 0, and our answer just would be y is equal to x cubed. Okay, so for another example, I'm going to let dy dx equal 2x minus 7 and y is equal to 0 when x equals 2. And the way the question is worded is solve the initial value problem for y. So we're going to start, and by initial value, we're talking about these. These are the initial value. So the antiderivative is going to be x squared minus 7x plus c. And then we substitute y is equal to 0 and x is equal to 2 into the equation. So y is 0, 2 is x, so that's a 4. And that means that c is going to be 10. Now, that's not our answer. Our answer is the equation once 10 is plugged back in, right here. Now we can do these problems with a lot of different applications, such as cosine and sine. So let's do a trig one. And so 1 plus cosine x, and y is equal to 4 when, this isn't equal, when x is equal to 0. So start with taking the antiderivative. So x plus sine x plus c. Substitute in the 4, substitute in the 0, solve for c, plug c back in. And that is initial values, differential equations, indefinite integral problems, solving for c.